Lesson number 30, daily summary. In this lesson, we solve equations that include algebraic fractions. For the last 3 lessons, we've been combining algebraic fractions together. We've reduced single algebraic fractions, and then we talked about how to multiply 2 algebraic fractions, or divide 2 of them, or add 2 of them, or subtract 2 of them. So this is the first and only time we're actually going to be solving equations involving algebraic fractions. So at the end of the day, the problems in today's lesson will have answers like x equals 5, as opposed to the answers in the previous 3 lessons, which were expressions involving x's at the end. Okay, I'm going to read this paragraph number 1, but know that it's not going to make a lot of sense until we've done this example on this page. But I'll come back and kind of summarize it at the end. But here's number 1. When solving equations, once we get all the fractions to have a common denominator by completing them with what's missing, just as before, we multiply both sides of the equation by the common denominator, which gets rid of all the denominators. When solving equations with algebraic fractions, it is absolutely mandatory to check your answers by substituting them back into the original equation. Like I said, that probably doesn't mean a whole heck of a lot at this moment, but let's try this example, and then we'll come back to that paragraph. Okay, let's solve this equation. 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. Okay, step 1, written here on the left in English, factor all denominators. Okay, this first term is a 2, it has an invisible 1 as a denominator. So I'm just going to give myself some space to fill in. Put the 2 on the top, and you could put the 1 on the bottom if you want, but we're going to fill in that blank space soon enough. This fraction right here, that denominator is already factored, or I guess I should say there's nothing to do in that one. All I've done is give myself a little bit of space over here in case I need to complete something that's missing. But this denominator, there's work to do. X squared minus 2x has a greatest common factor of x. So you pull the x out and you're left with x minus 2. That's right there. And again, with some space. Okay, we are now going to complete these denominators, make them all the same as each other. So let's look at the first 2 denominators. The first denominator doesn't have anything. The second denominator has x minus 2. So I suppose for sure this denominator needs an x minus 2. Parentheses around that one. Probably need parentheses there later. Let's go ahead and give a bag to the 2. Looking at the first 2 denominators, we see they are now the same. So let's look at the third denominator. It has an x minus 2. That's great, but it also has an x, which means that this first denominator now needs an x. Top and bottom. The second denominator also needs an x, which means it needs parentheses now. X on top and bottom. And is the last denominator missing anything from the first 2 denominators? No, all 3 denominators are exactly the same right now. Okay, so we've done this work to make the denominators the same. So here's the nice part. We actually get to now get rid of all of the denominators. All 3 of them are about to magically vanish, except it's not magic. We're going to do something very reasonable. We're going to multiply both sides of this equation by the same thing. And the thing we're going to multiply by is the lowest common denominator. It's highlighted up here in yellow. The common denominator for all 3 fractions is x times x minus 2. We're going to multiply both sides by x and x minus 2. It's legal because we're doing the same thing to both sides. So the right-hand side, the x and the x minus 2 cancel beautifully with the denominator. X goes away, x minus 2 goes away, and we're just left with plain old 8. Wonderful. Good things happen on the left-hand side too, but it's less obvious on the left-hand side. But we'll do this just the one time. This x minus 2 is on the outside of a big bracket, and there's a plus sign separating the 2 terms inside of that bracket. And that means that this x minus 2 is going to distribute to both terms. I'm not going to write anything, but I'm going to say a lot. Hopefully you'll stay with me here. I'm imagining this x minus 2 next to the first fraction and also next to the second fraction after it's distributed. And it's on the top, right? There's an invisible over 1 here. So imagine this x minus 2 next to the first fraction only after we've distributed. The x's cancel, the x minus 2's cancel. All we're left with is this 2x minus 2. It's right there. This x minus 2 also distributed to the second fraction. So imagine it next to the second fraction. The x cancels, the x minus 2's cancel, and we're just left with 4x right there. And so by multiplying both sides by the lowest common denominator, all of those denominators cancel, and we're just left with a simpler equation involving the numerators only. But note that we had to go through the work of making the denominators the same in order for this really, really nice thing to happen. This only worked because we got all of these denominators to be the same. Then they all disappeared. The denominators are not the same here. You wouldn't have had everything canceling perfectly in all of your denominators if you were to multiply up here both sides by x and x minus 2. So make those denominators the same first, then multiply both sides by the common denominator, and then all the denominators cancel wonderfully. So let's see what happens here. This 2x is distributing to the x minus 2, so it's there, 2x squared minus 4x. That is just 4x, which is here, and that is just 8, which is there. The 4x's happen to cancel, so we just get 2x squared equals 8. We'll divide both sides by 2 and get x squared equals 4. Obviously x equals 2, but don't forget that this equation is going to have 2 answers. When you take the square root of both sides of an equation, you got to put in a plus or minus. You might know whatever the highest power is in the equation, that's how many answers you are going to get. That is the fundamental theorem of algebra. So plus or minus 2, those are the 2 answers. All right, let's come back up to this paragraph that didn't have a lot of meaning before. When solving equations, once we get all the fractions to have a common denominator by completing them with what's missing just as before, we multiply both sides of the equation by the common denominator, which gets rid of all the denominators. So we did that. When solving equations with algebraic fractions, it is absolutely mandatory to check your answers by substituting them back into the original. All right, so this was not mandatory, at least not for me, for the equations we solved this semester. But for the first and only time this semester, it is mandatory to check your answers. So let me write the original equation. 2 plus 4 over x minus 2 equals 8 over x squared minus 4 minus 2x. Yeah. Okay, so let's go ahead and check our answers. So if we take our x equals negative 2, right, we had 2 answers, 2 and negative 2. Let's take negative 2 and plug it in for all of the x's. So that's this x right here, and right here, and right here. And you can see that I've carefully typed exactly this equation, but the x's became negative 2's, all of them. Okay, and also notice that I put a question mark above the equal sign because I'm checking my work. I'm assuming it's going to be equal, but I don't know that it's equal just yet. All right, negative 2 minus 2, careful, that's not 0, it's negative 4. 4 divided by negative 4 is negative 1. How much is 2 minus 1? Well, that's just 1. Let's look at the right-hand side now. Negative 2 squared, careful there, that's positive 4. Minus 2 times negative 2, that's another plus 4. And so 4 plus 4 is 8, and 8 over 8 is 1. 2 minus 1 equals 1, you bet. So that equation is true, that x equals negative 2. X equals negative 2 is a valid solution. Let's take a look at what happens when we plug x equals 2 in, so that's here. And again, it's all 3 of these x's becoming the number 2. So 2 minus 2, 2 squared minus 2 times 2. That's exactly what I've written here. And now we've got a problem. 2 minus 2 is 0, and 4 divided by 0 is undefined. Not that it matters, but 2 squared minus 2 times 2 is also 0. It's, I guess technically both sides of the equation are undefined, but x equals 2 is not a solution. You're not even allowed to plug x equals 2 into the equation in the first place. It gives you two fractions actually that are undefined. So since the last equation involves division by 0, x equals 2 is not a valid solution. Therefore, x equals negative 2 is the only solution. And this is really odd and somewhat troubling. We got 2 answers, 2 and negative 2. And yet one of them didn't work. It's not that we made a mistake. We were supposed to get x equals 2, even though it doesn't actually solve the equation. So somewhat discomforting, but when solving equations where there are x's in denominators, turns out sometimes this just happens through no fault of your own. You get an extra solution or an extraneous solution. So you got to check with these equations. I will give you a shortcut. Check with your teacher to see whether or not they are okay with you doing this shortcut. It turns out that to check whether or not something is going to be a solution, it only matters whether or not you're going to end up with division by 0. So for example, if you gave me this equation right here, and you said, hey, Ian, I got x equals 5, but I don't want to go through the work of checking to see if that works. Well, all you got to do is plug 5 there, just the bottom. 5 minus 2 is 3. Super. It's not 0. That part's no problem. 5 squared is 25 minus 2 times 5. That's 25 minus 10 is 15. Not 0. I don't have to do the rest of the check. That's going to work. As long as you did everything correctly, getting to x equals 5. x equals 5 will be a valid solution. So it's really enough with these equations in the check. You got to check, but a shortcut for the check is to just plug in the value of x into all of your denominators and check to see if you have any division by 0. If you have division by 0, then that value of x is not a solution. But if there is no division by 0, then you can be assured that your value of x is going to be a valid solution, assuming you did all the math up until that point correctly. Okay, so that's what I just said is written out here in this important note. This is the very last lesson of the course. Know that as I make this video in an empty classroom on a Saturday at 5:15 in the evening, know that I am rooting for you, even though I have possibly not met you and possibly will never meet you. I wish you all the best in your final exam in this class. Hope you study real hard between now and then. Good luck on that and your other finals with your education and beyond. Take care.